So, we are given a big F function. It's defined from x to 3x of 1 over t dt. And they ask us to find f prime. Well, please, please, please just recognize this as a second fundamental theorem question. Okay? Don't integrate and then take the derivative. All right? F prime just means that the integral and the derivative undo each other. We plug in our upper limit, if there's a variable in it, times its derivative. In this case, our lower limit also has a variable, so we do have to subtract that. 1 over plugging in the lower limit, and in this case, its derivative is 1. So, let's see here. When we simplify, we have 1 over x minus 1 over x, and that is 0.
Wow.
Yeah. Okay. So, technically, this, if you were to actually integrate this, it would involve the natural log and then take the derivative, but we don't have to do that. It's just a second fundamental theorem question. All you do is plug in your limits, multiply by the derivative of the limits. Okay? Questions like this before. Okay, they give us a function, and they give us these other constant functions. It's kind of like, what the heck are they for? Find the area of the region bounded by the graphs of the equations. So here's what they are for. So x equals 0, what is that? That is that vertical line on the y-axis. Y equals 0 is the horizontal line, which is the x-axis. X equals 2 is indicating the end of our interval, okay? Secant looks somewhat something like this. So we are finding the area under the curve. So what these two numbers right here are telling us, they're telling us the limits to our integration. We're going to integrate from 0 to 2 of secant of pi x over 6. I did not say the 2 because I put the 2 on the outside. What? That's the graph of the function. It says find the area of the region bounded by the graphs of the equations. I'm just sketching out all of this stuff right here. That y equals 0 is the x-axis, x equals 0 is the y-axis, x equals 2 is the other vertical line. I'm just giving you the visual.
Oh, okay. And then this right here is
and this is what we're actually, yes, the curve is secant. Okay? So, all that really doesn't matter. I just wanted to give you the visual representation of what all those equations mean, because we're just going to use the integral. What? The secant, the function that they gave us right there. Okay, so if we're going to integrate secant of pi x over 6, what do we need to do? Use substitution. We need to take that pi over 6x out. Du over dx is pi over 6. We don't have pi over 6 in our problem, so it becomes 6 over pi du is going to replace dx. Let me try and keep this color coordinated here. So the 6 over pi goes in front. Now, something that we can do, we can adjust our limits so that we don't have to worry about plugging it back in. All right, so if we plug in 0 into our u, pi over 6 times 0 is still 0. I'm losing my color coordination. Did you say what? I'm adjusting my limits. Since I'm doing u substitution with definite integration, we can change our limits, and that way we don't have to plug u back into the problem. We did that a way back. Okay, so u is pi over 6 times x, so our lower limit was 0, so it remains 0. We plug in the upper limit of 2, so our upper limit now becomes pi over 3. Secant of u du. Now, what is the antiderivative of, let's see, we've got 12 over pi. What is the antiderivative of secant? Thank you very much. It's positive? Yes. Co's are the negative ones. Okay, so at this point, the reason why I changed my limits was so that I don't have to plug the pi over 6x back in there. Okay, I'm just going to leave it as u and make my life a little bit easier. So leave the 12 over pi out front. The natural log of the absolute value of the secant of pi over 3 plus the tangent of pi over 3 minus the natural log of the absolute value of the secant of 0 plus the tangent of 0. And some of y'all need to get your work a little bit more organized when you're doing these because it is a nightmare grading your quizzes, and they're not going to put that much effort into trying to grade it for your response problem. I promise you. It needs to be linear. You can't have numbers everywhere. Okay? All right, so, trig. Okay, secant of pi over 3. Secant is the reciprocal of cosine. So what is the cosine of pi over 3? 1/2.
Yeah.
So its reciprocal is 2. Tangent of pi over 3. So we just said the cosine of pi over 3 is 1/2. So that means the sine is square root of 3 over 2. So we've got square root of 3 over 2 over 1/2. What does that reduce to? Square root of 3.
Yeah,
Square root of 3 over 2 over 1/2 is just going to leave you with the square root of 3.
Okay.
Secant of 0. Well, what's the cosine of 0? 1. What is the tangent of 0? 0, because sine of 0 is 0. Now, 1 plus 0 is 1. What's the natural log of 1? 0. So our final answer is 12 over pi natural log of the absolute value, or actually we don't need absolute value anymore because 2 plus square root of 3 is positive. No. And that's it. That is the area under the curve. Now obviously that's a nasty negative number, but, or not negative, but decimal number, but we just leave it in that form. Okay?
Pretty
Yeah, not too bad.
I'm saying.
Okay, one more. Find the average value of the function over the interval. Average value, what does that mean?
Integral.
Not just the integral.
Accumulation.
Nope. That is not funny.
I was trying, so. No, like, average value is something integral.
Yes, it does have to do with the integral. Yes, sir.
Thank you.
Yes. No, because it was definite integration. Paul was messing with people. Okay. So average value, when you see average value, that's 1 over b minus a times the integral from a to b of your function. So, for this function, 8 over x squared. We're going to have to integrate, so I'm going to go ahead and write that as 8x to the negative 2. So average value, we have 1 over b minus a times the integral. I'm going to go ahead and pull the 8 out from a to b of the function. Uh, 1 minus 4 over 2 is 2, 1/2. The integral of x to the negative 2 is what? Very good. Negative x to the negative 1. We're evaluating that from 2 to 4. So we've got 4 in front times negative 1/4 plus 1/2. Because we're subtracting a nickel. Negative 1/4 plus 1/2 is what? Positive 1/4. So the average value of this function from 2 to 4 is 1. Now, something to be noted. When you're doing these problems and they involve rational functions like this, you need to make sure that your interval does not include the discontinuity. Where is a over x squared discontinuous? No. No.
0.
0. It's discontinuous at 0. A over x squared is discontinuous at 0, because that's where the denominator would be equal to 0. Our interval does not include 0, so we're okay. Okay, 2 to 4 doesn't include 0, we're fine. If it included 0, you could not calculate the average value. You couldn't calculate the derivative, or not the derivative, the integral from negative 2 to 2, because you've got infinite area around 0. So just throwing that point out there. Okay, so